Section 3.4 from OpenStax Calculus Volume 2. Okay, this section is going to cover partial fractions. So, what we are looking at is rational functions here. Okay, this is the method of partial fraction decomposition. And it works when we have rational functions. And sometimes we have things that can be easily integrable, that are easily integrated, such as 1 over x, which would be the natural log of x, which we will need to know that a whole lot today. So oftentimes, though, we don't have something that's easily integrated. So this is where this is going to work. So let's start with something of the form p of x over q of x, where the degree of the numerator is greater than or equal to the degree of the denominator. Okay, if that's the case, then long division is a first shot. Okay, so let's go ahead and take this right here, and I'm going to do some long division. We're going to divide x squared plus 3x plus 5 by x plus 1, which will be, we will get x, so then that's x squared plus 1x. Subtracting, we get 2x plus 5, so then we have x plus 2, 2 times x plus 1, 2x plus 2, and we get 3. So this is plus 3, a remainder of 3 divided by x plus 1. So this is the same as the integral of x plus 2 plus 3 over x plus 1 dx. Now we can integrate those pieces very easily. This is going to be x squared over 2 plus 2x plus 3 times the natural log, the absolute value of x plus 1 plus c. Now that is based on u substitution. I would suggest, if you aren't sure where that's coming from, pause this and take a moment to figure out what's going on, because we're going to use that fact, this one right here, repeatedly. The integral of 3 over x plus 1 is 3 natural log absolute value of x plus 1. It's going to come up in almost every problem. All right, number 44, we'll do this. Take the same idea and do long division here. Now, we have x minus 3 divided by x plus 2. So we're going to have, this is going to be 1, goes in there one time, which will make x plus 2. Subtracting, we get 5. So this is minus 5 over x plus 2. Right, so this is the same as the integral of 1 minus 5 over x minus 2 dx. All right, and the integral there is x minus 5, natural log of the absolute value of x minus 2 plus c. Okay, so far nothing crazy. All we've done is long division. Now, if the degree of the numerator is less than the degree of the denominator, then we might factor some things and write them as a sum of expressions. This is where method of partial fraction decomposition, and why it's called that, comes in. So first, I'm going to factor this. It's going to be 3x plus 2 in the numerator. That will be x times x squared minus x minus 2. And that factors as well. So dx is the integral of 3x plus 2 over x, and that will be x plus 1 and x minus 2. Now let's just verify that. Plus 1. Yep, that works. Okay. Now, we are going to find some constants. Okay, so that this, I'm going to rewrite this actually. I want to find constants so that the integral of 3x plus 2, or actually I'm not even going to need the integral, so that 3x plus 2 over x times x plus 1 times x minus 2 is equal to a over x plus b over x plus 1 plus c over x minus 2. We're going to do quite a bit of algebra. Okay, so we've got a nice little equation here. Well, if we multiplied by the denominator, x times x plus 1 times x minus 2, this will yield this equation. 3x plus 2 equals a times x plus 1, x minus 2. plus b times x minus 2 plus c times x, put that outside my parentheses, x plus 1. Now I need to find the values of a, b, and c. That's what I'm after. Alright, so I'm going to choose some particular values of x. Okay, so first I'm going to take, what if x equals 2? Now you can maybe see why I'm doing that, because I have these x minus 2 factors in there. So if I plug in 2, that is going to be 8. 8 equals, the first term is 0, the second term is 0, this is c, x is 2, and x plus 1 is 3. So c times 6 is 8, so that means that c is 4/3. Okay, so going back up here, I'm going to have this later. C is 4/3. Now let's pick another value of x. Let's say x equals 0. Okay, x equals 0 is going to eliminate the last two terms. So this means I have 2 equals a times 1 times negative 2. The other two cancel out. And this tells me that a is going to be negative 1. Plugging that in there, there's negative 1. Last value I'm going to pick, let's use negative 1. X is negative 1. If I plug that in, that will be negative 1 equals 0, 0, okay, b, and then x is negative 1, and x minus 2 is negative 3, which makes b equal to negative 1/3. Okay, b is equal to negative 1/3. Alright, now, I'm using this algebra. Most of this work is algebra. And this means I have this is my integral. Negative 1 over x plus, I'm going to go ahead and write negative 1/3 here, over x plus 1 plus 4/3 over x minus 2 dx. And the integral here, it's all scratch work. This integral is negative natural log absolute value of x minus 1/3 natural log absolute value of x plus 1 plus 4/3 natural log absolute value of x minus 2 plus c. Okay, take a good long look at that, okay, and make sure you understand what is going on here. And then let's go ahead and look at number 46. Alright. Again, we'll want to factor our denominator, so this is going to be equal to the integral x squared plus 3x plus 1 over x plus 2, x minus 2 dx. Alright, now there are going to be constants, so that x squared plus 3x plus 1 over x plus 2, x minus 2, so that this equals a divided by x plus 2 plus b divided by x minus 2. Okay, now clearing those fractions, we get x squared plus 3x plus 1 equals a times x minus 2. And notice that I'm not actually distributing anything here. Okay, I'm just canceling those factors because it makes it easier to plug some values in. So I get b times x plus 2. All right, now let's choose a couple of values. 2 and negative 2 are good choices here. If x is 2, then that means 2 squared, so 4 plus 6, so that's 11, equals, the first term cancels, and I get b times 4, which makes b equal to 11 over 4. Alright, so let me just mark that here, that's 11 over 4. Now let's make x negative 2. Squaring that to be 4 minus 6, that's negative 2, so that's negative 1 equals, okay, negative 1 equals, the second term cancels out, so this is a times negative 3. So this makes a equal to positive 1/3. a second. -2. Oh, that'd be -4 right there. Something didn't seem right. That would be a -4, which will make this a 1/4. Alright, so this integral over here, again, scratch work. It's all over here. This is the integral of 1/4 over x plus 2 plus 11 over 4 over x minus 2 dx. And this will be 1/4 natural log absolute value of x plus 2 plus 11 over 4 natural log absolute value of x minus 2 plus c. Alright, moving on to number 47. Hold the phone. We have cosines and sines. Okay, so first we need to make some substitutions here. Alright, so choosing cosine to be u, if I do u substitution, choosing cosine is not a very good choice because the sine is in the denominator. So that's not going to work too well. So I'm going to go ahead and choose sine x to be u, which makes my du equal to cosine x dx. So we'll first write this as the integral of du. So I'm going to write this 1 du, and this is u squared minus u. Alright, now factoring that is 1 over u times u minus 1 du. And we are going to write this as partial fractions. We're going to have something over u plus something over u minus 1. And this is where our algebra is going to come in. Alright, so we have 1 over u minus 1 equals a over u plus b over u minus 1. Clearing those fractions, we get a times u minus 1 plus b times u. Right, now let's make a choice of u equals 0. If u equals 0, then this means we have 1 equals a times -1. So a is -1. So put that right in there. Alright, if u equals +1, or +1, then I determine 1 equals b. Well, so b is 1. Okay. Now, integrating this, we get negative natural log absolute value of u plus natural log absolute value u minus 1 plus c, and of course, substituting back in, u is sine plus natural log absolute of sine x minus 1 plus c. Right. Nothing crazier. Okay, so next, this one's already factored, so we really need to go straight to our algebra. Okay, go straight to our algebra. It's going to be the integral of something over x plus 3 plus something over x minus 2. Let's find out what those are. So x plus 1 over x plus 3 x minus 2 equals a over x plus 3 plus b over x minus 2. Clearing our fractions, we have x plus 1 equals a times x minus 2 plus b times x plus 3. Okay, a choice of x equals 2 will work great to find b. So that would give us the equation 3 equals 0, and then that is b times 6. So b is 1/2. Hold on, something's not right there. That's 5. How did I do that? I keep making these simple algebra mistakes here. Or algebra, these are actually just addition mistakes. Alright, times 5, so that's 3/5. Okay. 3/5 there. So b is 3/5. Okay, now a choice of x equals -3 will give us -2 equals a times -5, and that's a 0. So a equals 2/5. Alright, once we've got the algebra taken care of, the integral of that is 2/5 natural log absolute value of x plus 3 plus 3/5 natural log absolute value of x minus 2 plus c. Okay, and there we are. Okay, next we have number 49. Right, now there is a slight difference here because you can factor this. It's going to have a 2x minus 1 and a 2x minus 1. Okay, nothing's happened there. So something slightly different we're going to have to do. This is going to be written in this way. Something a divided by 2x minus 1 plus something over 2x minus 1 squared plus something over x minus 1. That is going to be the only difference, okay? Because we have these, we kind of walk these powers up. We have 2x minus 1 to the first, 2x minus 1 squared, and then we've got our x minus 1. Okay, that's the one thing that's going to have to be just a little bit different. Now, you might wonder, do I really have to do this, or is it just it's just something people are telling me? Well, try it. Try it both ways and see if you get the same answer. If you do, the way that you're thinking you might do it, then, hey, it just might work. Okay, try it more times. Don't just try it once. There are special cases, but that's a possibility. So let's go with this. X minus 2 over 2x minus 1 squared times x minus 1. Okay, and I want this to be equal to a over 2x minus 1 plus b over 2x minus 1 squared plus c over x minus 1. All right, canceling out our denominators, multiplying that across, we get, let's see, one of those cancels out. So a times 2x minus 1 times x minus 1. You're going to have more pieces in here. Now with b, the 2x minus 1 squared cancels, so we have x minus 1. And with the c, we get 2x minus 1 squared. Again, some very smart choices. First, let's go with a value of 1. A value of 1 will give me -1 equals a times 1 times 0. So actually that first term cancels out. Right. The second term cancels out, and so we get c times, and plugging 1 in there, we get just 1. So c is -1. Okay, c is -1. Now, let me mark that out here. Or actually, I can just put that here. -1. All right, now let's find b. Let's go with a value of 1/2. A value of 1/2. That'll affect 2 of the 3. So plugging 1/2 in there, we get -3 over 2 equals 0, 0, and then b times -1/2. So solving that, we get a b value of 3. Okay. Now the only question there is what we are going to get for c. There are no other values we can use. So let's go ahead and use x equals 0. Okay, let's do x equals 0. This is not going to necessarily help, obviously, but if we plug that in, we get -2 equals a, we don't know what a is, so a times -1 times -1 plus b, we know what b is. B is 3, so 3 times -1 plus, we know what c is, it's -1 times 1. Alright, so simplifying that quite a bit, we get that a equals 2. all of this we are doing is just some algebra, solving a system of equations effectively. Okay, now what we are going to do if we take the integral of each of these, alright, well, my first thought is 2 natural log of absolute value of 2x minus 1. Okay, now we have to be careful about that because of the u substitution. We would have a factor of 2 in there. So I believe this is actually just going to be natural log of 2x minus 1. Natural log of 2x minus 1 minus 3, and this is going to be a power rule here, inverse power rule. We have negative 3 over 2, 3 over 2, 2x minus 1 squared. Okay, minus natural log of absolute value of x minus 1 plus c. Okay. Alright, so if we took the derivative of this ought to work out. Now the last one I see, the second one, I'm going to write this up here. If I had negative 3 over 2 times 2x minus 1 to the negative 2, if I took the derivative of that, that would get me a positive 3, 2x minus 1 to the negative 1, which is exactly, oh, should that be a 3 there? I think that should be a 3. Okay, well, I'm glad we noticed that. Okay, there it is. There should not be a squared on this term right here. So now let's continue to check that with differentiation. Let's make that just to the negative first. All right, negative first. So the derivative of that would be positive 3 over 2. Let's do this. Positive 3 over 2. Okay, and that would be to the negative 2 times the derivative of the inside there, which is 2, which gives us the middle term there. Okay, so keep in mind that you can always differentiate your answers, what you get from your integral. You can take the derivative, differentiate it, and it ought to come out to where it was, or where it began. So remember, you can always do that. Okay, this was the one that was a little bit trickier than those other ones. All right, next we have set up partial fraction decomposition for this expression. All right, now all this is asking us to do is come up with what those fractions are going to look like. Okay, A, B, C, D, E, etc. Okay, we don't necessarily have to solve these. So we know that we are going to have a fraction with an x plus 3. We know we're going to have a fraction with an x plus 3 squared. And we're walking up the chain there. A cubed term. Okay, now x minus 4 and an x minus 4 squared. So remember, we're kind of walking up the powers from x plus 3 up through cubed and x minus 4 up through squared. Okay, keep that in mind. Okay, now if a denominator does not factor completely, we modify this ever so slightly, okay, to include what I'm going to call linear coefficients. Okay. So let's go ahead and look at this one right here. Evaluate the integral of dx over x cubed minus 8. Okay, so to begin, we can factor this. Okay, I'll keep my dx in place. This will be a difference of cubes, so x minus 2, x squared plus 2x plus 4. And how this differs is because the x squared plus 2x plus 4 does not factor anymore. Okay, it's prime at that point over real numbers. Alright, so let's go about finding our coefficients. We'll write this fraction over here. We have 1 over x minus 2, x squared plus 2x plus 4. Now this is going to come out in this form. We're going to have the form a over x minus 2 plus bx plus c. This is where the linear coefficient comes in. X squared plus 2x plus 4. Okay, clearing those fractions, we get 1 equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. All right, now we're going to choose these wisely. We want to first start with x equals 2. Okay, if I choose x equals 2, this gives me the equation 1 equals a times 4 plus 4 plus 4, so that's 12. And the second term is 0, so a equals 1/12. Next, let's choose x equals 0. I'm using that because that's going to cancel out the b term, the bx there. So 1 equals, that'll be 4a, plus, we have a 0 there, so we just have c times negative 2. Well, we know what a is. A is 1/12. Okay, so that's 1/3. And so working that around, we get that c is I know I wrote this down somewhere. 2/3 divided by that, so we get negative 1/3. I could have done that without even looking at my paper. Okay, negative 1/3. All right, now next we have x equals 1. I'm going to choose that. All right, so that is going to be, if I plug that in, 1 equals a times, well, a is 1/12. And if I plug 1 into that function there, 1 plus 2, that is 7 there, plus, we don't know what b is, we do know what c is. All right, so if I plug 1 in, that is going to be b plus c times negative 1. Okay, now I do know what c is. C is negative 1/3. Okay. Alright, so then that means that our value of b, again, if we do a little bit of algebra, is negative 1/12. Alright, so the integral that we are considering, okay, and I'll go ahead and write this in this next page. Okay, the integral of x cubed minus 8, and we have dx over that, okay, is equal to the integral of 1/12 x minus 2 dx plus, and we have negative 1/12. Oh, actually, let's just do this, put it in one integral. Plus negative 1/12 x minus 1/3 over x squared plus 2x plus 4. And that's all with a dx. Alright, so I'm going to go ahead and factor a 1/12 term out of each of these. Actually, this first one, I know what that's going to be. That is 1/12 natural log absolute value of x minus 2. Okay. Now this next one, I'm going to factor a negative 1/12. So I'll make that minus 1/12. Now I have the integral of, that's going to be x plus 4 over x squared plus 2x plus 4 dx. Okay, now the second one we are going to need to split this up just a little. So I'm going to leave this term behind for just a moment. This is minus 1/12 integral of x over x squared plus 2x plus 4 dx minus 1/12 integral of 4 over x squared plus 2x plus 4 dx. Okay, now that second one is a u substitution. If we used u for the denominator, okay, and then du, we'd have a 2x plus 2. So what ends up happening there is we just get negative 1/24 natural log of x squared plus 2x plus 4. Okay, so we have one more step. We have 1/12 natural log x minus 2 minus that term, okay, minus whatever is going to happen there. Now we're going to need to do a little bit more algebra for this one, so I'll leave that alone. I'm going to go ahead and rewrite this as putting this in vertex form, x plus 1 squared plus 3. dx. Now for a piece of u substitution, okay, if u is x plus 1, then du is dx. Okay. Oh, actually, I meant to do my u substitution earlier. I hate to back this up, but I think I'm going to. I did not mean to split these up. Okay. This will work out nicer this way. Okay, so let's do u substitution here. So this is minus 1/12, okay, x plus 4. And this is going to be x plus 1 squared plus 3 dx. Okay, so if we do u equals x plus 1, du equals dx, x, okay, x plus 4 actually, is u plus 3. So I'm going to write this as minus 1/12 integral of u plus 3 over x, no x's, u squared plus 3. Okay. And I suppose I could keep this. Okay. Now, this I'm going to split up, okay, as negative 1/12 integral u over u squared plus 3. Okay. Minus 1/12, and that is going to be, actually I'll make that 3/12 or 1/4. Okay, so that is minus 1/4, okay, integral of 1 over u squared plus 3 du. Now this last part here, okay, this u squared plus 3, that is going to be an inverse tangent, okay, with an a value of square root of 3. So this is going to be 1/4, okay, and then we have times 1 over a, which is the square root of 3, inverse tangent of u over square root of 3. Alright, so let me bring down each of these pieces. I've got u squared plus 3, 1/12, natural log x minus 2. Okay. Now we'll back up on our u substitution on that last one. And now the middle term is actually going to be negative 1/24 natural log of u. And once we actually do some backtracking and work, we get x squared plus 2x plus 4 for that. Negative 1/24 there. Okay. Now this other one over here, when I rationalize the denominator, I'm going to get the square root of 3 over 12. Inverse tangent of x plus 1, that is my u, over square root of 3. And 1/12 natural log absolute value of x minus 2. That is the integral, plus c. Okay, so I say we modify it slightly. Really, the new thing here was how we got the coefficients. Okay, so I'm going to skip back here. The actual getting the coefficients part of this is the part that was new. Okay, that's the method that changed. The rest of it was just, that's just old stuff. Okay, trigonometric integrals, inverse trigonometric integrals. So keep in mind, this is the new stuff, and this, don't let it overwhelm you at all, because we've actually done all of this before. We just always need a nice little reminder of those things. Okay, last question. Set up partial fraction decomposition for this. So, as we had earlier, this is going to be a over x plus 2 plus b over x minus 3 to the first power plus c x minus 3 squared plus, x squared plus 4 is what we're going to put in here. But that does not factor, okay, it's irreducible, so we're actually going to use that linear coefficient, as I would call it. And then last, x squared plus 4 squared, so we'll have fx plus g. We will hardly ever need that many variables, but that's how that would break down. Okay, that is the end of our partial fraction decomposition section. So go back through, make sure that you understand everything that's happening, and ask questions if you don't. That's it.